In this video, we're going to discuss the command hierarchy in TrueGrid. You can think of the command hierarchy as being synonymous with the order of operations in a mathematical equation. It's important to understand the command hierarchy because it determines what commands are executed in which order. There are three overriding rules that apply. Rule number 1, vertices, edges, faces, and volumes are automatically calculated in that order: vertices, edges, faces, and volumes. Rule number 2, commands are executed in the order according to the command type. We'll see that in the table. Rule number 3, commands of the same type are executed in the order they are issued. These rules are explained in the 2-page command hierarchy table found in your training guide. In TrueGrid, the order in which you issue commands is not the order that they're executed. You don't need to be concerned about the order that you issue, add, delete, or change commands throughout the mesh building process. TrueGrid will execute them in the correct order. This table is known as the command hierarchy. It is necessary to understand the ordering and dependencies to build a complex model. The command hierarchies are broken up into 5 different categories of events. In summary, first, we position vertices to initialize and project. Then we position edges to interpolate or attach and project. Then we position faces to extrapolate and project. Then we interpolate interiors using interpolation and smoothing. Lastly, we sometimes apply expressions, algebraic modifications, by coordinates and indices, but this is rare.
And in particular, the initializations are always done first, and then the projections are done, so that the initializations will be used to direct the projection. The first one is the positioning of all of the vertices. Remember, the vertices are the corners of the blocks, and they're always done first. That includes the PB command, the block boundary command, the curve commands. So now that the coordinates of the vertice has been set, only then does it do the projection. Now, once the vertices are done, then edges are interpolated between the vertices. Just a simple interpolation. Using the two end vertices as the boundary conditions for the interpolation. This is done automatically. It's the default. You can control that, but by default, every edge is done independently. Once they have been interpolated, then they're projected to the required surface or surfaces. Once all the edges are in place, starts with 0-dimensional vertices, 1-dimensional edges, and as you might guess, the next one is 2-dimensional faces. Each face independently is interpolated. That is, all of the nodes on the inside of the face are interpolated, given coordinates based upon the position of the nodes on the boundary edges. And once they have been interpolated, that is, the nodes on the interior have been interpolated, then they are projected. Now, it's a little more complicated when relaxation or Thomas Middlecoff or uniform are involved, because it's not a one-step process, but the principle is still the same. First, it interpolates, then it projects. Then it uses the relax first iteration to move things around a little bit, and then reproject, and then move all the interior nodes around again a little bit, and then project. So it's back and forth between smoothing and projecting, back and forth. So if you do 300 iterations, 300 times each node is smoothed a little bit and reprojected. Still basically the same idea. It first interpolates and then it projects. Now, the fourth and final objects that are manipulated are going to be the solids, the brick elements, the interior of a solid brick part. And there's no projection taking place with these solids. They're only interpolated and smoothed. No projection, because you can't project a solid onto a surface. Now, the last thing you'll see here is expressions. And what it did was, for each node, it used the coordinates of that node in the expression and made an assignment to that same node. So you can use these algebraic variables to change the coordinates of the nodes, but it's rarely used.